Okay, so this is problem 6 from chapter 4, and we have a circuit that has a 144 volt voltage source here, ideal voltage source, and there's a 4 ohm resistor there, and connected in a T configuration is a 10 ohm resistor, 80 ohms across here with a 3 amp current source going into that node, and then a 5 ohm resistor here. This is the voltage drop across the 10 ohm is called V1, and the voltage drop across the 3 amp source is called V2. And we're asked to find V1 and V2. So we're going to use the node voltage method for finding the voltage source for V1 and V2 because it's laid out for, it seems to be laid out for that. You certainly wouldn't use Kcl at this point, but I can't remember in the book if they've talked about, not Kcl, but I mean KVL, which would be the other method. But the node voltage source is basically Kcl. And the, so what we're going to do is the most obvious choice for the reference source is the ground. So everything will be done with respect to ground. So let's begin. So at our equation, our Kcl equation, so we'll do, this is going to be with respect to V1 and V2. So Kcl at V1 is going to be V1 minus 144 volts over 4 ohms. That's the current into that node. And then now we need to find the current through that branch. That's that branch current. Now we need to find this branch current. So that's going to be just V1 over 10 ohms. And then that branch current is going to be V1 minus V2 over 80. That's equal to 0. So the sum of all the currents through a node has to, current in has to equal current out. So notice that this is not 3 amps, so because when it goes here, the current can split either going this way or that way. So we have to use the node voltage method to find that branch current. So now we do Kcl at V2. There. Well, that's going to be V2 right here minus V1 over 80 plus, and we have the current going into the branch, so it's going to be plus negative 3 amps plus, and then this branch here, well, what is that branch current? This resistor is in parallel with this resistor, so it has to have the same voltage drop. And I is equal to V over R, therefore this branch current is V2 over 5 ohms, and the sum of that is equal to 0. Now, we're going to lay this out in matrix form. V1, V2 is equal to. Okay, so the coefficient for V1 in the first equation is 1, 4, right? And then here we have negative 144 over 4. That's going to be brought over here to become a positive, so we have 144 over 4 over here. Coefficient for V1 again, plus 110 plus 180. Those are all my coefficients for V1. And then for V2 I have a negative 180. Okay, over here we have coefficient for V2 is 180. And then over here V1 negative 180. And the 3 amps is going to be brought over here. So I have 3 over here. And then V2 has a coefficient of 1, 5. So 1 over 5. Notice that I have symmetry across there. So if you don't have some kind of symmetry, then double check your coefficients. You have a plus minus error somewhere because Kcl is symmetric. So use your simultaneous equation solver. We have 2 equations and 2 unknowns. and we just put in all the coefficients, 1 divided by 4, plus 1 divided by 10, plus 1 divided by 80. Enter, oops, yes, negative 1 divided by 80, 144 divided by 4, and then negative 1 divided by 36, oopsies, negative 1 divided by 80, 180 plus 1/5, and 3. Then hit F5 for solve. Oops, and I have a mistake somewhere. 180, 144 over 4, 180. Okay, so let's do this again. Okay, so we have 1 divided by 4 plus 1 divided by 10 plus 1 divided by 80. Enter. Negative 1 divided by 80. Enter. 144 divided by 4. Enter. Negative 1 divided by 80. Enter. 1 divided by 80 plus 1 divided by 5. Enter. 3. Enter. Solve. 104 is 110, 180, 144 was the 3. 180, 180 plus 1/5. I have a mistake somewhere. 144, I was trying. 144 over 4, 110, 180, 1 divided by 4, plus 1 divided by 10, plus 1 divided by 80, enter. Negative 1 divided by 80, enter. 144 divided by 4, enter. Negative 1 divided by 80, enter. 1 divided by 80 plus 1 divided by 5, enter. 1 divided by 80 plus 1 divided by 5, enter. Negative 1 divided by 80, enter. 23, enter. Okay, so all these figures are correct. V1 is equal to 100 volts. V2 is equal to 20 volts. The issue that I had was not that the setup of the equations was wrong. The issue I had was with my simultaneous equation solver. It's very easy to make mistakes when you're entering fractions, and that's what I did. So I guess as far as troubleshooting goes, if you have symmetry in the diagonal columns, you're looking pretty good. If you don't have some kind of symmetry, then double check your signs. You probably have a sign error somewhere. You've probably done something like added a branch current going into a node, but as you can see, it's pretty easy to make mistakes here. Also check like you could do what I did, which is you might fat finger entering the fractions. So be very careful when entering that, because we're dealing with fractions, and it's easy to enter it wrong. Okay, that's the end of this one.